And we are now recording. So and get my whiteboard up. Okay. All right. There should be a few other folks who will jump into this session as we go, so I'll have to pause and admit them in. And all right, so this is again 2.2 and dealing with multiplying, dividing fractions. And so I'm just going to work the problems as I see them pop up. And this is number 1. So just some fractional work. And the first problem is just 17 times 3 and 1/17. All right, so we got a multiplication problem. And this is what we call mixed fraction. Now, understand a mixed fraction in and of itself. Here would be the one circumstance that's not multiplication. It's not 3 times 1/17. When you have a mixed fraction, it is actually 3 plus 1/17. Okay. Now, so now if I were to look at if I were to actually do the arithmetic, and we'll get to actually multiplying this here in a second. I'm just talking about mixed fractions real quick. If I were to add these up, to add fractions, you have to have the same denominator, the number in the bottom. And right now this is a hidden number. If you have 3, it's the same as 3 over 1. Hidden number 1. Now, multiplying fractions, you multiply top, multiply by bottom. And to rewrite a fraction with a different denominator, again, I can only multiply by 1. That is, top and bottom must be the same. And I choose 17 because I want these each to have the same denominator. So 17 times 1 on the bottom is 17. And 17 times 3 is 51. And then 51/17 plus 1/17, and that is once you have the denominators the same, you add the numerators over that common denominator. So I end up with 52 over 17. Okay. And I apologize. I keep looking here to make sure we don't have anyone else trying to jump in here. This over here. Now, yeah, and you can do that. You can add these up every time, and then we get the fractional form of 3 1/17, that mixed fraction, into what we call improper form. Now, this is just terminology. An improper form doesn't mean it's bad. Probably not the most well-named term. It is what it is. It just means the numerator is bigger than the denominator. When the numerator, the top, is smaller than the bottom, it's called proper. But again, and typically, as you move, like if you went into an algebra course, we don't worry about mixed fractions. We just leave them in improper form. However, There is an easier way besides just adding these up, if that is converting from mixed to improper form. So another way to convert it is to simply do this. Take the fractional part, this times this plus this, and that gives you your numerator over whatever that denominator was of the fractional part. Notice I just end up going 17 times 3, which is 51, plus 1 is 52/17. So that's much far easier than this. So the thing to realize, again, if you have a mixed fraction, is it's this plus this. And to actually do the conversion, it's this times the whole part plus the numerator of the fractional part. And that gives you this improper form here. Now, to convert back to mixed fraction, it's 17 divided into the top, or the denominator divided into the numerator, how many ever times it goes, and the remainder of that division goes here, and again the 17 stops there. So that's how you convert back and forth. Now we're going to turn our attention to this. How do we actually do this problem here? To multiply. If it's adding mixed fractions, that's a lot easier. If it's multiplying, write this in improper form. That's why I went through all this. So, and then it's 17 times, and then we already have converted this to 52 over 17. And then I multiplied. Now, again, multiplying fractions, it's multiply across the top, multiply across the bottom, then reduce. And we know this is 17 over 1. Now, you can reduce it before you ever multiply. If you know that you've got factors between top and bottom that cancel, go ahead and cancel. Like the 17 here and 17 here cancel, which would leave me now 52 in the top and 1 in the bottom, which is 52. So that is your answer. All right. Number 2 is exceedingly easy. It says, what's the reciprocal of 6/7? And so here's that word reciprocal. So it wants to know, what is the reciprocal of 6/7? So today in 120 class, I said the easier word, smaller word, synonymous with reciprocal is flip. Just flip it. So the reciprocal is 7/6. Now, when you go to type in your answer, you're typing in a fraction. As soon as you click into the answer field, you get a toolbar at the bottom. There is a fraction. You'll see the fraction tool right on the left side, and you can click it. Another way to do it, and this is just FYI, you can use that toolbar every time. It's fine, but you can use the backslash key as a shortcut. That is, I can type 6, hit the backslash key, and you'll see it then gives you that fraction. And then it wants the denominator, and so it's 7/6 was my answer here, people. And so it's just a shortcut, but you get the toolbar, the fractional tool, when you type into the answer field. All right, so reciprocal just means flip. All right. Number 3. So I'm going to turn the page. And number 3 is division of fractions, and the problem here is 3/8 divided by 3/40. So again, as we discussed in class there today, if you're dividing fractions, you flip the divide by part, which is referred to as the divisor, which you're dividing by, and multiply. So division of fractions becomes 3/8 times 40/3. And here the 3's would cancel, top and bottom. Now that leaves me with 40, because then when it cancels, that leaves you a factor of 1 here and here. And that gives me 40/8. Now, you always have to reduce your answer. That's one thing about MyMathLab I really like, is it insists. That means there are no common factors between top and bottom. That is, there is no number that will divide both into the bottom and the top. But notice here, 4 goes into 40. That is 40 divided by 4 goes in there 10 times. 4 goes into 8 2 times. Now, that still reduces. That is, 2 goes into 2 once, and 2 goes into 10 5 times. Now, I could have easily gotten from here to here very quickly if I had just said 8 divides into 8 once, and 8 divides into 45 times. But however you get there is fine, as long as it's we call completely reduced. Now, I actually could have, when I initially did this and I flipped, I could have just said and wrote it like this. 3 goes into 3 once, 3 goes into 3 once, or the 3's cancel, and 8 goes into 8 once, and 8 goes in there 5 times, and it's 5. Any way you look at it, it's 5. Any questions on that one? All right, number 4.
Hey, Chris, how do you
Yes,
know
sir.
what equation we use? I found the answer. I knew what you were talking about, but I didn't understand the equation per se.
Okay, so first off, just so we're clear here, we're not working with an equation. This is just a verbiage thing here. That is something you deal with. You have a variable, and we're solving an equation. We're trying to find a value that makes both sides true. Give me a second here. It makes both sides true. So I have to be careful just with the wording here. So what you have here is just an operation. So now let's step back. Your question was, how do I know what equation I'm using? Or so we want to kind of rephrase it. How do I know which operation? Is that fair enough?
Yeah, I guess I didn't know the terminology, but yes.
Yeah, and that's we're learning. So you aren't looking at the problem like I'm looking. I'm looking at the actual problem. So when you're doing the problem, I'm going to read what the instructions. We back up here to that problem. The problem says divide. And so that the instructions say divide, write your answer in lowest terms and as a whole or mixed number if possible. So that's the instruction. So you're dividing. Then when you look at the problem itself, where's my cursor? There we go. You'll see the divide symbol, and it's read 3/8 divided by 3/40. So you're dividing. 2 different ways. One, the instructions, the very first word says divide, period. And then write answer in lowest terms, so on and so forth. So you know that this is the first thing you're wanting to do here is flip this because you're dividing. And again, 2 ways in the words of the instructions, and 2, you'll see this. I mean, I'm just writing down the problem as I see it, as it's given. So even if I did not have that instructions which said divide, as soon as I see this, I read this as 3/8 divided by 3/40. And then I know, how do I divide fractions? I divide by taking the divide by part. And that is just so you read the problem just like you would read a sentence, left to right. 3/8 divided by 3/40. And so it's that divide by part that you want to flip. And that's how you know it becomes 3/8 times 40/3. Does that make sense?
Is that the only one that you do it with? If you're using division, you flip that to, and then you multiply?
Yes. So in general, division rule is this: if I have any fraction a over b divided by c over d, so any fraction where a and b are just some numbers divided by c over d, then this is always going to be a over b times, and then again, you see how I flip that, and then I multiply.
Okay.
So that is the rule for division. Right. So, Dave, does that help?
Yes, it does, especially when you read.
Okay. So the next problem, number and I'm going to go ahead and turn the page here. Where's my eraser? Number, this was still number 3. The next problem on number 4, you're going to see the exact same set of instructions. Divide, period. Write the answer in lowest terms or as a whole or a mixed number if possible. But you're going to notice it's written differently. You don't see the divide symbol. It's written like this. It's like a fraction over a fraction. All right. So a fraction, any fraction, and if you think about the divide symbol itself, it looks like if you see the fraction bar and then a dot over a dot. A fraction is division in and of itself. I mean, it's so if I write the fraction, separate that out. I write the fraction 2/3. That is always a fraction is numerator divided by denominator. 2 divided by 3. So if I see this 7/6 fraction bar over 4 divided by 3, and you'll note how it's written, you make this middle bar a little bit longer to indicate, this is the top fraction, and down here is a fraction 4/3. But it is 7. This is, and you don't have to write all this out, but it is 7/6 divided by 4/3. That's how I read it. Now, this is known, this right here, when I write it in this form, it is known as a complex fraction. A complex fraction is a fraction in which the top and or the bottom is a fraction. And how do I simplify it? It's division. It's 7/6 divided by 4/3. So we already know that. How do I handle this? It's 7/6 times the flip of 4/3, which is 3/4. And then I'd multiply. Now, I can go ahead before I multiply across the top and multiply across the bottom. I know 3 goes into 3 once and 3 goes into 6 twice. Then 7 times 1 is 7, and 2 times 4 is 8. And so your answer here is 7/8. Any questions on that? Okay. So I'm going to turn the page. Now looking at number 5. So number 5 is just like number 4. Number 3, the instructions say divide, but your problem looks like this: 8 over 4 over, actually the longer fraction bar here was here, 8 over 4/9. But you do this in the same manner. So your top is 8. That is like 8 over 1 divided by 4 over 9. So this is my divide by part. I'm going to flip it. So I have 8 over 1 times, then 9/4. Then 4 goes into 4 once, 4 goes into 8 twice. And I can finish this off by 2 times 9 is 18, and 8 and 1 times 1 is 1, which is just write it as 18. Okay, 6 is more of the same. And number 7 is kind of like an application type problem. All right. So it says, I'm just reading the problem. A recipe for loaf cake. I'm not sure what loaf cake is, but loaf cake, the recipe for it calls for 3/4 pounds of jelly beans in assorted colors. If 8 cakes are needed, how many pounds of jelly beans will be used? Now, and that's very typical recipes. Recipes have generally a lot of fractions involved. If I made this a little easier problem and said, well, I called for 4 pounds of jelly beans for 1 loaf cake and you needed 8 cakes, then it would be 8 times 4, you need 32 pounds. So the operation doesn't change if it's fractions. It's just, I'm going to have to multiply what? 3/4 pounds of jelly beans times 8, and whatever this comes out to be. Now, it was multiplication. So it's 3/4 times 8 over 1. Now, the 4 goes into 4 once, and 4 goes into 8 twice. So it ends up 1 times 1 on the bottom, which is 1, and 3 times 2, which is 6. So I would need 6 pounds of jelly beans. Questions on that?
Can you go through that one more time, especially the second part of it?
Well, since it said each cake needed 3/4 of a pound, and you needed, that's for 1 cake, and you needed 8 cakes, that would be adding 3/4 plus 3/4 plus 3/4 plus 3/4 8 times. And so multiplication just says 3/4 times 8. So all I'm doing is multiplying these two. And so that's where I wrote it 3/4 times. And the 8, and you don't have to do this. I'm putting it in there just so we can see my numerators and my denominators. So I wrote the 8 as 8 over 1. Now, you can go ahead and go 3 times 8 is 24. And 4 times 1 is 4, which would give you 24 over 4. But 24 over 4, 4 goes into 4 once, and 4 goes into 24 6 times, or 24 over 4. 4 divided into 24 is 6. So what I'm doing here is I'm canceling out like factors before I multiply, so that I know my final answer will be reduced. And now, so I got 1 and 3, but 4 goes into 4 once, and I wrote a 1 here. And then that 4 goes into 8 twice. And this is where I cancel it out and I write the 2. And once I have my like factors canceled out, then I go ahead and multiply my numerators and multiply my denominators. Now 3 times 2 is 6. In the bottom, 1 times 1 is 1. So, but if it's 6 over 1, we would just write that as 6. Are we good there?
Yes.
Okay. All right. Now, number 8. Number 8 is multiplying. Can't write. Multiplying two fractions. They're both mixed in mixed fractional form. 5 1/3 times 5 3/4. So what you're going to have to do to multiply these two is you're going to have to rewrite each of those in improper form. And then once I have that, I'll multiply the two fractions. So remember, the easiest way to convert this from mixed form to improper form is to take this 3, the bottom, times the whole part plus the numerator. 3 times 5 is 15. And 15 plus 1 is 16. So it's 16/3. The denominator in the improper form will be the denominator of the fractional part of the mixed fraction every time. So this times this plus this gives me my numerator, and my denominator is this. So converting this one in the same fashion, 4 times 5 is 20, and 20 plus 3 is 23 over 4. Now I go ahead and multiply. Now I'm going to reduce, I'm going to cancel out like factors just like I had been every time. So I can say 4 goes into 4 once, and 4 goes into 16 4 times. And then there are no other factors to cancel out. And I know that because 23 is prime. So it only has 2 factors, one in itself. So I can go ahead and multiply 4 times 23. And so 4 times 23 is 92. And then 3 times 1 is 3. Now, you're not going to have the option here of typing in 92 over 3. If you do that, I want to see what happens if you do. I mean, in terms of what it's going to tell you it's wrong. But it's a question of how it tells you it's wrong. I'm going to see if it, sometimes like this, it will say correct answer or incorrect form. And it just says it's incorrect. Now, 92/3 is actually, again, in a higher level math course, I would be fine with 92/3. However, the reason it's counting it wrong, in the blue, right below the answer field, it says simplify your answer, type a whole number, proper fraction, or mixed number. Now, remember, proper means top is less than the bottom. So you're going to have to now, this is the first one we've seen where I'm going to have to take this and convert it to a mixed fraction. So remember, to convert from improper back to mixed fraction, take the bottom, divide it into the top. How many times that division goes is the whole part of the mixed fraction. That is on my calculator. I'll just punch in 92 divided by 3. Now, you get on your calculator 30 point and then 6 repeating. Now, one, for this particular one, 6 repeating like that, 0.66666 forever and ever and ever, is 2/3. But the way I figure out, now I know in the mixed part, the denominator here is 3. To figure up the numerator, it's the remainder of the division. And the way I figure that up is 30 times 3 is 90, and I take that away. So I was dividing by 3. It went 30 times. So this times this is 90, and 92 minus 90 is 2. So I'm now typing in 30. Oh, actually, on your answer field, when you click into the answer field and you go down to the toolbar, you'll see one of the boxes for mixed fraction. It has 3 parts to it. The whole part, which again was 30 here. Oops. Why did it do that? 30. And 2 in the top. And 3 in the bottom, or 3. Okay. Okay. And one other thing about this problem. Should point out here. So your answer is 30 2/3 is a mixed fraction. The actual first part of this problem on number 8, it wants you to estimate the answer. So let's do that. That's your exact answer. If I were to estimate this answer, and that's the first thing it actually wants, the estimate, you want to simply round this to a whole number. And you use the same kind of rounding technique as you would if you were working with decimals. If it's more than 0.5, you round, or the number's more than 5 or more, you round up the last digit up. And if it's 4 or less, you leave as is. Well, I look at the third. It's a question of, is this a half or more, the fractional part, or is it less? Well, a third is less than a half. So I'll estimate 5. But I'll estimate here 3/4 is more than a half. So I'll estimate that is 6. And my estimate here is going to be 30. The actual answer was 30 2/3. So the first answer it wants is that estimate, which again is 30. And then we put in the exact answer, which was 30 2/3. And I'm just having trouble typing. That is it. So be careful on that. I just don't want you to get frustrated. So make a note on number 8. That first one has to be the estimate. If you try to type in the exact answer there, it's going to count you wrong, simply because you weren't giving the estimate. And the way, again, we get the estimate is round this to the nearest whole number. And the way you estimate a mixed fraction is look at the fractional part. If it's more, half or more, round that up. If it's less than, as in this one, 5 1/3, a third is less than a half, then leave as is. So that's where I got the 5. And this one, I rounded to 6 because 3/4 was more than a half. So questions on number 8? All right. So 10 has division of mixed fractions. You would write each in improper form and then flip the divide by part. 11 is much the same, and so is it 12. So question 14 just deals with the terminology of like fractions and unlike fractions. Like fractions are fractions with the same denominator. Unlike fractions have different denominators. So it gives you 2/9 and 4/5. Those would be unlike. The denominator 2/9 is 9. The denominator 4/5 is 5. So they are unlike. And this gets to addition of fractions. You have to have, which we did a little bit earlier, you have to have the same denominator. So if they're like, it's a piece of cake. So when adding, which gets you to the next problem, number 15, gives you 1/18 plus 1/18. Now, adding fractions again, this is where you need to have the same denominator. And to add them, you add the numerators over that common denominator, and that is 1 plus 1, adding up your numerators, is 2, and then reduce, if possible. And here it would reduce. 2 goes into 2 once, and 2 goes into 18 9 times. So your answer here would be 1/9. 16 has you adding up a couple of fractions that are like. 17 does the same thing. 18 has you subtracting like fractions. 19. Okay, so you get to number 20. Yeah, I think I put number 20 in right here. Is the first one that you have to deal with rewriting a fraction with a different denominator. It gives you 7/12. And it says write with denominator, abbreviating, of 84. All right, so how do I, and we did this again earlier in the session here. So you're just rewriting this fraction in an equivalent form. So which is 7/12 is like what we say completely reduced. So we're going back the opposite direction. Now, what if I want to get to a denominator of 84? What I think to myself is, what do I need to multiply 12 by to get 84? And that is 7. Now, 7 times 12 is 84. Now, again, you're not changing, because if you multiply the bottom only by that and you left us at 7, 7/12 and 7/84, so it's not the same number. The only way not to change this is to multiply by 1. And so whatever you multiply the bottom by to get your desired denominator, just make sure you multiply the numerator by the same thing, because then you're just multiplying by 7/7. Now 7 times 7 is 49. So your answer here would be rewriting 7. Oh, shoot. Rewriting the stray marks. Rewriting 7/12 with the denominator 84 would result in 49/84. And you're going to do the same thing with number 21, and that is it. And that's all I'm going to assign today is this 2.2 working with fractions. And just about out of time. So today is 23rd. So I'm going to make this due on the 27th as well. And so I have assigned 2.2. All right, doesn't appear anybody else jumped into this session. I will go ahead and stop